My name's Martin Chilvers. I'm the field crops pathologist here at Michigan State. I guess you guys have already heard about the wheat head scab from Eric and the setup of that trial, so I won't go into too much detail there. But I guess before I do that, I'll just give you a couple of introductions. So this is Mikaela Breunig. She's a PhD student in my lab who's been working on head scab for the last 4 years now. Dr. Frances Trail, her lab really focuses on head scab and the biology of that, and Tara Watkins, a PhD student from her lab as well. So just as Eric had sort of explained to you about the misted trials that he's got going on for breeding, right, we're using these misted trials really to look at management of head scab, okay? So most of this is ambassador, which is a very susceptible cultivar, right? So it's very susceptible to leaf diseases and to head scab. We do have three passes of Dynagro 9242, a resistant check there. So it's also a soft white variety, but it's far more resistant to head scab. Okay, and so we do the same sort of treatments to that to see the effect of that resistance compared to this really susceptible variety. In terms of trying to manage head scab, variety resistance is really, really important, right? That's far more important to think about and use than a fungicide. Fungicides are excellent tools, but we see year in and year out that just using a resistant variety provides the most protection from head scab, okay? And so out here we've got a number of different trials. One of those is a coordinated study. So it's done here, it's done in about 5 other states across the country, and that's coordinated through the United States Wheat Barley Head Scab Initiative, okay? And by coordinating those trials, it allows us to look at a lot of different data points over time, right? Because we might get really favorable conditions here, or we might not, but in other states, we can look at how their data performed this particular season too, and look at it overall. So for that particular trial, at the moment, we're examining this new chemistry from Syngenta, a Miravis Ace. So that one we're looking at timing and also follow-up fungicide applications beyond that initial application at flowering. Can we get additional benefit by stacking an extra chemistry on top a few days later? Okay, and we're comparing that to the standards that we've been using for a while now, the Prosaro and Carumba. Those types of chemistries are all a similar mode of action, so they're all DMIs or triazoles. This Miravis Ace has that triazole, but it's also got a different type of chemistry, what's called an SDHI. So we're excited about that in terms of resistance management. And I'll hand it over to Mikaela to talk about that in just a second. The other piece that we've got in here as well is some private trials with companies. So the companies will come to us and work with us in terms of what we've got going on out here to screen new products that are coming through the pipeline, right? So there'll be numbered compounds, it'll all be confidential. But what happens is that it gives us a few years to work with that product prior to it being labelled and you actually seeing it. So we can advise as to the efficacy that we see from that particular product, and certainly work with the companies in trying to make sure we screen as best we can to see how that product's going to perform and get the most information out of it. So that's what we've got going on in the misted area. Mikaela's also got some foliar fungicide trials as well, and I'll hand it on to her to discuss those.
So Marty mentioned resistance management. So, you probably see a lot in the news about resistance building up in weeds to chemistries, and that's something we have to worry about with these fungi as well, these pathogens. So especially in head scab, a lot of growers use the triazoles, the same kind of chemistries every year, because that's the only thing that's labeled right now. So that's something that we wanted to kind of monitor and see if we have any resistance problems. So when I got here 4 summers ago, I started collecting head scab samples from both wheat and a little bit from corn, and started isolating these different fungi that are causing this disease. And then I looked at them in lab assays, and I did find some differences. So some of these isolates, most of them were very sensitive to these chemistries still, but there were some isolates that were about 10-fold different and didn't respond as well to that chemistry. So then we're wondering, this difference we see in the lab, does that translate to a difference in efficacy out here? So we set up a trial in this back corner here, non-misted, so it's just natural conditions for disease development, and we sprayed on these different isolates of fungi in a single plot. So one plot would only have one strain of this fungus that's either resistant or sensitive, and then we'll either not spray it with carumba, or spray it with Folicure, which is tebuconazole. And then at the end of the season, so in a few weeks here, we'll do disease ratings and compare and see if that efficacy we get from those fungicide applications is different between those sensitive or resistant strains we found in the lab. So hopefully we won't see a difference between those isolates like we saw in the lab, which means that there's not really resistance building and we can keep using these triazole chemistries. If we do see a reduction in efficacy from that resistance, then we might want to use some of these other modes of action more often now that we have something available besides triazoles. So stay tuned, and we'll keep you guys updated, especially at those winter meetings, what we find. So that kind of wraps up for head scab. Is there any questions on head scab before we talk about foliar diseases? That's good. We must have talked perfectly, Marty. So for foliar diseases, that's also a concern, especially in years like this where we've had a lot of rain and those cooler temperatures for most of the season. So Septoria is something we're seeing out here at pretty high levels. Martin Nagelkirk said that by his estimations, he thinks it's about a 10% yield loss from Septoria out here we'll see. So I've been here 4 summers and I've seen Septoria every summer, but this is the first summer that I've seen it so severe on the flag leaf. So I think because we've had that continued rainfall, it's been able to keep reproducing and move up that canopy, and that's why we're seeing it on that flag leaf this early in the summer, right as we're going into grain fill. So the good news is if people made flowering applications for head scab, that's going to give you some protection on that flag leaf as well against foliar diseases. And there's a chart on your handout that also talks about the efficacy for foliar diseases. So besides Septoria, I've seen a little bit of powdery mildew, and we've also found a few both stripe rust and leaf rust. So those are both rusts, but just different species. So we've seen both of them out here, but at very low levels right now. But if we continue to get cooler, wetter weather, that could definitely explode and become more of a problem towards the end of grain fill. Do you guys remember in 2016 when we had stripe rust really bad? Anyone get burned that year? So that's kind of the first year that stripe rust came on our radar as being maybe a yield problem. So we wanted to set up some timing trials looking at specifically for foliar disease. We have plenty of trials for head scab, but we really wanted to narrow in for foliar diseases. When is the best time to apply to help protect your yield? So we have that trial we've done for a couple years now set up in our backfield, which you can't see right now. It's to the right of those orchards back there. And there we have different timings we've sprayed of the same fungicide, so we can just compare the timings at T1, which is that Feek 6, which we find normally is probably a little too early if that's your only application. It's not going to protect the flag leaf at this stage. Then we sprayed at when the flag leaf was fully emerged at Feek 9, and then we sprayed at flowering last week when the flowers were out. So at the end of the season, we can kind of compare, and we also did different combinations of those two, although we might not always be able to afford 2 applications, but at least we can see our potential for control that way. So when we're nearing the end of grain fill, we'll do final ratings and we'll be able to really look and see which of those treatments performed best. Right now in that backfield, there's not much of a difference between those treatments, but as if we get that weather that's wet in the next few weeks, I think we'll be able to start to see a big difference on those different timings. Any questions on foliar diseases or fungicide timings? Then I'll turn it over to Frances.
Hi, I'm Frances Trail, and I focus mostly on Fusarium head blight and trying to figure out some different approaches to control. And one of the things that we've been working on in the last few years is trying to find some naturally occurring fungal and bacterial strains which are antagonistic to the head blight pathogen. So we've gone out and collected isolates of fungi and bacteria in fields that have a 3-crop rotation, corn, soy, and wheat. And then we've brought those into the lab and tested them in the greenhouse for their ability to protect both at the seedling stage and at the heading stage wheat plants from Fusarium graminearum. So at the seedling stage, we found a number of isolates, all fungal, that if we inoculate the seeds, roll the seeds in spores, then as the seedlings grow, they are resistant to Fusarium graminearum. If you inoculate those pots that have the seedlings in them, they will not develop head blight symptoms. And in fact, when we look, we can tell that Fusarium graminearum has been totally prohibited from entering those plants. So that's been something that we're working on. And we're now starting to look at taking that to the field. We want to introduce a group of these fungi at once onto the seeds, hoping that if we have a group that as the field conditions vary, 1 or 2 of those strains will be able to have the right conditions to protect. In terms of the heading out stage, we've looked at, well, I should say that as seedlings grow, it's hard to find strains that will stay inside the wheat, the beneficial strains, all the way until it heads out. So we're also looking for that, but we're also looking at strains that we could spray on as a flower spray. We could spray on the fungus and it would protect from infecting spores. And recently, and this is preliminary data, but it's repeatable in the greenhouse, we can apply a strain we have, a fungus, to the flowering heads, and it reduces dawn. So we're really excited about that, and we're pursuing both trying to find more strains like that and also figuring out how we can package this and how it can be used in the field. We have a second project that's kind of something new, and I'm going to turn it over to Tara Watkins, my PhD student, because she's working on it. She's going to talk about it.
Hi, so as Frances said, I am working on a new project, and to explain that project, I'm actually going to take us all back to high school biology or whatever biology class you had last. So we know we have DNA in any organism, right? And so the DNA encodes for genes, and there are obviously many genes in the fungus. Some of them that we have identified are crucial to things like Canidia germination, ascospore germination, parathecia development, which parathecia are the small black fruiting bodies that produce the ascospores that will then get on the plant and start an infection. And so we have identified some of these genes that play a role in these processes of the fungus germinating and beginning to cause disease on the wheat heads. And so what we can do by using these genes is after we have DNA, then we go to RNA, right? Everybody following me? It's RNA where we begin to get gene expression. And so there's a new method that people are working out in other fungi that we are hoping that we can translate to Fusarium graminearum, where we can make these molecules to target these specific genes. And once they target these specific genes in the cellular level, those genes can be broken down. And basically what that means is after they're degraded, those genes can no longer play a function in the role of spore germination or whatever it is that we are targeting. So if we can target these genes and break them down, and we can spray this product on the plants, then we can hopefully greatly reduce germination and thus greatly reduce the disease that we would see on the plants. And so, like I said, this is a spray. We would make these molecules and we would spray them on the plants themselves. The plants have the ability to absorb these molecules just as they would absorb a fungicide, and it will translocate to the fungus that is located, whether it be the spores or whether it be already germinated fungi, and we can greatly reduce the disease process. So that's the goal. As Francis said, it's a very new project. It's in its first year. So there's still many years ahead before we can actually get something like this out in the field, and the possibility of you guys to use it in your fields as well. But like I said, other people have used it in other fungal models and cropping systems, so there is hope. Is there any questions about that?
For either one of us.
Yes, either one.
I forgot to ask for questions.
No? Okay.
Thank you.
Nagelkirk, you have any extra comments?
No, well, we have a couple minutes, maybe. Who has sprayed for scab already? Or intends to yet? Yeah, yeah, it's quite a mixed bag across the state. I guess the southern tier has been flowering for a couple of weeks, but in the thumb in northern Michigan, we're still a week away. But one of the tough questions with the commodities prices the way they are and the stands the way they are, it's pretty tough to know whether or not to treat or not. I will say, in terms of the U.S. scab initiative model that we look at on the computer, and we can share that address. Did you say it was in the fact sheet?
Yes, it's on that handout. Yep.
But that's something to cross-reference when you're considering that. One of my concerns is for a variety such as this, an ambassador, and we don't grow it a lot anymore, is that Septoria, as Mikaela mentioned, because that's a big deal. That flag leaf's going to be burned off there in about a week to 10 days. It's going to be no more. So that's important, the leaf diseases. But the scab, there is definitely some risk this year, and although the humidity hasn't been so bad, but there is some risk. But if you have a pretty good yield potential, I would certainly encourage you to do that. There are more airplanes being lined up this year just because many cannot drive through the field at this juncture, and if we have the next couple of days with some more rainfall, that could be pretty tough. But that's one of the biggest things this year. The other thing that really strikes me this year, besides the difficulty we've had with wheat starting last fall and this winter and compounded again this spring, is how late the crop is. I do not recall flowering this late. I don't know if you guys have, but not in the last 20 years I have not. And so it's really interesting. That does not mean that we're in trouble, I don't think. As long as it stays cool and we have ample moisture, we still should have some pretty decent yields. But it is very interesting. It's a real contrast to past years. The one reason I wonder about it sometimes, we are going to get a different mix of diseases. With this kind of weather pattern, it always affects that. And so if you know your varieties, it's a big deal. This variety, for example, will get twice as much scab as another variety you might grow. It makes that much difference. In some of the better reds, it's 3 times as much. In terms of a disease, leaf diseases, it's day and night. So a year like this, the variety really matters. And so take a look and make sure you know your profile of susceptibility for each of your varieties. And if you're not sure, check with one of us and we can give you a couple of references. But that really matters this year. Any questions or comments? Corrections? Tara's afraid of questions on DNA, so she's running. We didn't have DNA when I was in high school.
That might explain a lot.
In fact, you speaking of my DNA, or?
I'm not saying anymore.
I think we're good.
I have a question. Did you induce for Septoria out here too?
Nope. That's all natural.
I've looked at a lot of wheat and I haven't seen it like this.
Yeah, so it's probably the variety.
Okay, but I've looked at a lot of that variety and
Really?
I haven't seen it.
Yeah, Ambassador is one of the most sensitive to Septoria, and it started early, but I have other varieties too, and I'm finding it there, and we always do. If you have wheat, you have Septoria, but it's a question of that variety being able to resist it. This one can't do that, but it rarely have I seen it don't know if I've ever seen it so aggressive so early on the flag leaf. Last year, for example, in a hot season, we can get spotting on some of these varieties too. In that case, when it's warm, it's really a different leaf spot, but it looks the same. But the point is, this is pretty significant, and there's a few other varieties, so I'd watch for it definitely. There's no excuse.
Different locations yesterday, looking at a whole bunch of varieties, not just ours, and we didn't see any of them.
What county are you in?
We're in Carson City area and Ovid area.
Oh, I'm surprised. I think you will.
Yeah, go back in a week.
Oh no, yeah. But there's really no reason. There should never be leaf disease at flowering. As soon as that flag leaf, it's only been out for Pete's sakes for a couple weeks, and if it's dirty already, that doesn't bode well for a variety that can't resist it very well. But yeah, it's down. And some of the more pretty good packaged wheats, I've seen it low down, not severe. Not that I'd be concerned, but it's always there. Just like powdery mildew is always there. Septoria is the other one. In March and April, you start seeing it way down in the lower canopy. Then it's just a question of where it goes from here. Here it's doing pretty well for itself. Couple of thoughts. Another wagon asked, and I like this question. If we have quite a bit of prevented planting, what's the prospect from going wheat last year, prevented planting, and then this fall planting wheat again? It's pretty convenient if you're not going to get everything planted. I'd caution a couple of things. First of all, just from general, and this is just me. One of the things we accumulate over time when we have barren soil is that we do accumulate some nitrogen. I would not put nitrogen on that crop if you're going to go wheat, fallow wheat, because nitrogen is released. You'll find 30-40 pounds free nitrogen there. The other thing, on poorly drained soils, back in '96 we had this, and it was just repeated across the area. If we had fallow ground, we're following wheat, fallow ground that fall, that September, well, it's available, we're going to plant it. We had quite a bit of take-all. Take-all is a soil-borne disease that affects wheat and can cause quite a bit of lodging. Our varieties are doing a little bit better than they used to, but I'd be a little cautious. The only thing I'd suggest in a wheat fallow field, wheat rotation is it's the only time I'm ever going to say this, don't plant especially early. Not September 10. For take-all, we get a little bit of suppression, or it helps ourselves a little bit if we don't jump the gun too much. I'd probably wait till, depending on where you are, but latter part of September, early October, especially in non-tiled fields where problems can be confounded. And then also don't plant real thick, an early planted wheat. If you are going to go corn, fallow, wheat, you're going to go early September, back off on that seeding rate, and most of the best wheat growers, or half the best wheat growers in the state, disagree. I'd only ask that at least half of the field or so do a couple of splits and back off on that seeding rate, and I think it makes a difference as well. How many are still going to spray for fusarium? You're all north of here yet, maybe? Yeah. Did I say that? I think our mid-October planting is still in the thumb, is still a week away. And so we got a ways to wait. Our September planted wheat probably to be this weekend or so.
But we only have 2 weeks to dry out.
Yeah. And so it may not get done. If you are going to fly on wheat, and I wish we could do some studies, but it's really hard to tie down airplanes and have them fly at the same time. But the question I get quite a bit is, what's the value of an aerial applied fungicide treatment versus ground? I still prefer ground, partly because I'm old school, but there is pretty good evidence and experience now that airplanes can do a fairly good job. The one good fact sheet, I think, out of the Dakotas, and Michigan was involved in that study too, suggests that 30 pounds pressure for these planes. The nozzle should sit maybe get away from the wing just a little bit by 12 inches. We should be looking at a height of 8 to 12 feet if they dare, and it can do pretty good. I really feel it'll do a fine job on leaf diseases, but on scab deposition on that head, it seems to do quite well, and I wouldn't be too afraid of it. It's a little bit more costly, but if you can't get through the field, that's still an alternative if your agribusiness is lining that up. Brasaro, Carumba, Miravis Ace, they're all fine for this, and I would probably be influenced by price. Some retailers, when checking some of the prices, that depends which retailer you're talking about, but be price conscious, and I know you are.
What kind of pressure
What pressure? Doesn't seem to matter. It's more of a question of droplet size. You know, some of these guys, and I know it makes you feel good, but they want to race across these fields, or I don't care what speed you go, but don't get that pressure so high, and so you're fogging it. That's great in a greenhouse maybe, or for, I don't know, delousing, but it's not for scab. We don't want to see that mist. That's too fine. We don't get enough deposition on that head. And so I can run my 01s, Turbo T-Jets 01 at 30, 35, and I'm happy. So it's a question of that droplet size for me, more than anything else, and then proper pattern. But man, and the pump matters, but I can get that at 30 pounds pressure. And other ones I go up to 50 pounds to get the size and the pattern I want, but it doesn't take much. Now don't get this confused with some other fungicide applications on other crops, because sometimes we do want to blow them around and make them quake, but not wheat.
Are we worried about losing fungicide local way?
No, well, I'm not, but I probably should be. Yes, we are. Camera's rolling. Fungicides are really safe, and actually a little bit of air movement. Today it's a little bit much, but it actually can help distribution, even by airplane, just a little bit of air movement. So I'm not talking 10, 15, yeah, then of course. It'll really, if you use these papers, it will move your pattern. And so definitely 10 miles, 8 miles, it really does. It moves off, and usually we're spraying something else is legal, but we want to keep it there. But it really matters. Even when you check the deposition on the head, you can tell which way the wind is blowing. It's that sensitive. So I'm not as sensitive about it as I am with Roundup and some other herbicides, because I trust that it's going to help me in some ways. But so yes and no, Dwight. I'm talking both ways, I know.
Might be our sign up.
Okay. All right, thanks.